In this video, we'll be talking about integration by parts, and the learning objectives are 1. Finding the antiderivative using integration by parts, and 2. Using the tabular method to perform integration by parts.
This is the integral of u dv is equal to uv minus the integral of v du. So I'm going to show a proof of this actually. So let's say we're taking the differential of uv with respect to dx, of course. So, well, that's the product rule, so we can say that the differential of uv is u v prime plus u prime v. So another way of writing the v prime and the u prime is to say v dv over dx for v prime, and for u prime we could say du over dx. Okay, so since dx is a common term within each of these terms, we can actually just erase this, giving us the differential of uv is equal to u dv plus duv. So let's take the integral of each of these terms, and let me just rewrite this. So the integral of the differential of uv is equal to the integral of u dv plus the integral of v du. So we have this term integral of u dv, and we want to isolate that, so we take the integral of v du and we subtract it from the other side. So that leaves us with the integral of u dv equal to the integral of the differential of uv minus the integral of v du. So the integral of the differential of uv, that's simple, that's just equal to uv. So we can say uv minus the integral of v du, and we can say that's equal to the integral of u dv. So that gives us the original equation. That's a proof right there. So let's erase this and actually use this rule. So let's say this example that we're going to write, the integral of x e to the x dx. Well, we're going to find out what dv is equal to and what u is equal to. So those are our two terms. We want to find out which is which. So we say dv is equal to something, and then we have v equal to something, but then we also have u equal to something and du also equal to something. So let's try setting dv equal to x. So you can say dv is equal to x, and the integral of that would be x squared over 2. And this is actually wrong. It's a much more complicated way of doing this. You always want to take the easier term that you can take the antiderivative of. So we can say that u is equal to x and du is going to be the differential of x. So then we could say that dv is equal to e to the x, and v would just be equal to e to the x, and that would of course be plus c, can't forget that, and plus c over there too. But we're going to disregard that for now. It's not as important until the end. So here we have dv equaling e to the x, so let's box that off, and u equaling x, box that off. So in the equation we have the product, so the integral of x e to the x dx is equal to the product of u times v, so we have u and v, so we're going to say x times e to the x, and that minus the integral of v, which we said is e to the x, du, which we can also say is equal to dx, given our math. So when you take the integral of that, you get x e to the x minus e to the x plus that constant c that we wrote in earlier. So we have the integral of x e to the x dx equaling x e to the x minus e to the x plus c. And that is our final answer.
Here I'll be showing you integration by parts using the tabular method. If we're finding the integral of f of x times the function g of x dx, we can easily find the integral of these two functions if we use the tabular method, as long as one of these functions is easily derivable and the other we can integrate repeatedly easily. So if we use the example of the integral of x cubed times sine x dx, we can use the tabular method. We make one side for the derivative, the other side for the integral. We start off with x cubed. We then derive that to get 3x squared, 6x, 6, and then 0. Next we find the integral of sine of x. So we start with sine of x, integrate to get negative cosine x, then negative sine x, then cosine x, and then sine of x. The next step in this process is that we begin to multiply diagonally. So we start with the derivative x cubed times negative cosine x, and we continue diagonally this way throughout the whole chart. We'll also be multiplying both these functions by positive and negative alternating. So we start with positive, alternate to negative, go back to positive, so on and so forth. So as we begin to multiply these functions, we'll get negative x cubed cosine x, then we'll get positive 3x squared sine of x, then we'll get plus 6x cosine x, and then we'll get negative 6 sine x. And the reason why we stop repeating the integral there is because if we were to do that with 0, we would get 0, and if we would continue to derive 0, we would get 0. So we would just get plus the constant. Here I'm going to write it out more clearly. So the integration by parts of the integral x cubed times sine of x dx will be negative x cubed cosine x plus 3x sine x plus 6x cosine x minus 6 sine x plus the constant. This is how we integrate by parts using the tabular method.